Hi everyone, good morning. How's everyone doing? I hope you enjoyed your developer keynote and the early keynote this morning. It's really exciting to see you all here. So my name's Wayne Pekarski, and I'm a developer advocate here at Google. And today I'm really excited to talk to you about all the cool new things we've been doing on the Internet of Things. And this enables what we refer to as ubiquitous computing. So there's been a lot of new and interesting products and tools of interest to developers that I'm going to be highlighting in this talk. And some of them are being released at I/O right now. So there's been a whole bunch of new announcements during the keynotes. Yesterday we had Cloud IoT launching, so there's all kinds of new things. So we're going to do a sort of a whirlwind tour of all of Google's products that are related to this so that you can find out more of what you can do for yourself. So importantly, here at I/O, we have a whole bunch of really interesting engineers and PMs and leaders from all the different teams that work on these products that I'm going to be talking about. So make sure you take advantage of that and go and see them in the sandboxes and so forth. So let's get started with our little tour. So as we know, computing has evolved over the years. So we started from mainframes, and then we moved to desktops and laptops and then phones. And so every decade or so, we shrink our electronics, and now we're at wearables. The problem is that if we go any smaller than what's on a wearable, we run into the problem of that humans can't interact with them anymore because we can't make something that's smaller than this because our fingers can't touch it. So there's kind of a limit to what we can do with shrinking electronics. And what's happening now is that computers are being embedded into everyday devices. We use different devices depending on what we're trying to do. So we use a laptop to write documents or emails, a TV for videos, a phone for things when we're away from home, and a wearable when we're running, and something when we're driving. So there's all these different computing experiences that are suitable for what you're doing at the time. And now we're at a point where we have thermostats and light bulbs and basic electronics that are being internet enabled. But we can do a lot more than that. And we're moving to a world where computing is going to be everywhere, assisting users with their day and solving problems that we didn't even realize existed. And we're going to look back on this and go, wow, this really changed everything. So while phones were bigger than PCs, Internet of Things is going to be even bigger than phones. And it's going to be incredible. So we use the term ubiquitous computing to describe this. It's technology that's accessible to the user wherever they are and whenever they are and what they're trying to do. And so today we're going to talk about what platforms Google provides and what developer tools Google provides to help support this. So in the past, we trained users to install apps onto their phones, and they had icons. So you would click an icon for each app. And now we have devices that don't even have screens. So we need to think differently about computing and what it means. We need to take the user's context into consideration. So what time is it? What's the user's location? What are they doing? And we need to make good decisions for our products based on those kind of things. And you need to think of your platform as a view into your service now. So it's no longer just a single app or a single website. Your service needs to be ubiquitous, it needs to be everywhere, and it needs to work on all platforms. So we want a single, seamless experience to keep our users happy. So with that in mind, a little intro, let's get started talking about what consumer products are provided that consumers have right now. And we'll start talking with Android. So with Android, as you saw in the keynote today, they announced there's like 2 billion devices out there that are running Android. So that's incredible. And we have Android phones, we've got tablets, we've got wearables, we've got TV. And they all involve the same infrastructure. So they all work on Google Play. You build your apps using Android Studio, and the apps run on the device. So we do things like that right now, but many of you may have only written a phone app before. So one thing you might want to consider is also extending your app to run on Wear or Android TV. So last year I gave a talk at Google I/O that talked about how easy it is to port your apps to Android TV. There's a few tweaks in your manifest you've got to make, you change the UI a little bit, and then it runs on those devices as well. And so these are new opportunities to have different kinds of users looking at your application, because there are times when looking at something on a TV is better, and sometimes when a wearable is better, and you really need to take advantage of those things. Now, phones can do all kinds, Android in general does all kinds of interesting things. They do apps, games, they can do sensor processing, 3D graphics, audio. So there's all kinds of really interesting capabilities that we're going to get to talking about later on. I'm just going to highlight Android Auto as well. Android Auto is a little bit different in that it's a templated user interface in that you can build messaging and media apps as well. So if you're a company that makes media or messaging apps, you simply add some extensions to your Android app, and then it will work when the user plugs in their phone into a vehicle or when they install it into one of those cars that you can see out in the demo area. So we have this big ecosystem of Android devices that solve different needs. Now, there's no one device that's perfect for everything. Some are better than others depending on the context that the user is in, but they all solve different problems depending on the time, where the user is, whether at their home or in their living room. So that's Android. Now, you may have also heard at the keynote about Google Home and the Google Assistant. And so these are also platforms that we're going to cover today and explain how that fits into our vision of ubiquitous computing. We announced today that the Assistant is now available. It was available on Google Home, but now we're also announcing that it's going to be available on a lot of Android phones out there. And also, it's coming soon on Wear, TV, and Auto. So we're bringing the Assistant to all of these different platforms. And the Assistant allows the user to have a conversation with it to get things done. And so the basic Google Assistant is you talking to Google, but there's a third-party library that allows you to build your own extensions as well. And we'll get to talking about that soon. The Google Assistant is interesting because it supports both text and voice-based audio inputs and outputs. And once again, that depends on the context of what the user is doing. If they're in a movie theater, they can type on their phone. If they're driving, they can speak. If they're standing in the kitchen with their hands dirty, they can speak as well. So you use a different input and output modality depending on what the user is doing. So as we can see, context is important, and that's going to help us with all these platforms. So these were the consumer platforms. Now we're going to talk about the possibilities for you as a developer and how you can extend them. Consumers have these devices already. There's billions of phones and TVs and wearables and so forth out there. You want to be able to take advantage of them. And how can you do that? Because there's a bunch of new options that you're going to find very interesting. So the first thing that's really cool is that we announced recently the developer preview for Android Things. And so Android Things is Google's new platform to support the development of IoT devices, and it's based on Android. And one of the really interesting things about Android Things is the use of what we call a SOM, which you can see on the slides over there. Now, a SOM is a little tiny board that's got a CPU, memory, wireless, and all of the important things that make the device do what it does. And they're all on a single common board with a common set of software. Now, these SOMs are made in bulk quantities so that you can buy them in small quantities and pay reasonable prices for them. And you plug them into your own custom developer board to test them, but you can build your own custom development boards depending on your needs for the kind of application you're building, because you don't want to have to embed a full developer board into a product that you're selling. And so the SOM contains hard-to-design components. When you're doing electronics manufacture, you start to realize that there are like high-speed electronics and low-speed electronics. High-speed electronics require really skilled design people who really know how to build things that run at 1 gigahertz. And there's a lot of design rules you've got to take into place. Whereas low-speed electronics are the kind of things that we can build at home. So I've actually got a talk tomorrow where we're going to go through how to go about making your own boards for an Android Thing device that you can solder at home, basically. So we're going to talk about that tomorrow. But the nice thing about SOMs is that it's our initiative to democratize hardware development. And we're making it fun for prototyping, so anyone can take an Android Things board and build something, but there is a road to production. You don't have to switch hardware and switch your software platform. You can use the same hardware and software for both your prototype and the commercial product that you can sell in quantities. And that's one of the really important things about Android Things and our architecture based on SOMs. So the way you get started with Android Things is you start with one of these developer boards. So I've got some samples on the slide here, and you can see that the developer board is quite large. The SOM is plugged into it. The SOM is actually the really small component on the bottom left, and it's on the top left of the other one as well. So the SOM just plugs in, but the developer board has breakout pins for every interface you would need as a hacker or a maker or making prototypes. So there's USB ports, audio, GPIO pins, I2C buses, HDMI outputs, things like that. Now, you build your prototype, you put a breadboard next to it, you can run jumper wires across, and then when you finish, you can then take that custom board and shrink it down. But it's nice because you can test both and use the same SOM. So in tomorrow's talk, we're actually going to go through an example. So my colleague Dave actually built this LED candle project. So we wanted to test how hard it would be to make our own boards and then solder them in our own workshop. So you can see here on the left that Dave built a prototype which had a large board with the LEDs and resistors and wires on it plugged into the Edison debugging board, and we tested it. And once we were happy with it, then we used PCB software, we designed a schematic, and then we had the board fabricated. Now the board we fabricated very cheaply. There are lots of places nowadays that will fab boards for you really quickly and easily. And so you can see on the right that we have our LED prototype sitting in its plastic shell, and then there's a lid we put on top of it. And the board we built is almost the size of the SOM. And that's an example of how you can build a cheap board, build it in with a SOM, and then you can embed it into a component and sell it. So I was quite excited that we were able to hand solder this and build these prototypes. So it helps to increase the time that you can do for prototyping, because you don't want to have to wait a month every time you want to iterate on something, because electronics can be a little hard to do compared to software. So the nice thing about Android Things, and we have a bunch of talks at Google I/O specifically about Android Things, so definitely attend those if you're interested. But Android Things uses standard Android APIs to make IoT devices. It's a variant of Android in the same way that Wear is, same way that TV is, and the same way that tablets and phones are different variants. And so they all use the same Android code base to implement their features, and the same APIs are available. Use Android Studio to write your code. You can use your existing code base development tools, and you can hire any Android programmer to build IoT software for you now. Whereas in the past, you would have to hire someone who's familiar with microcontrollers and assembly language and low-level hardware. It's now a lot easier, and that's what we're really trying to do here. The other thing is that it's a real Android device, so it includes Google Play services with all of its features. So we've built a version of Google Play services that's reduced in size, so it uses less memory because it doesn't have as many features as a phone, for example. You're not making phone calls. But we have a special version of Google Play services that offers things like Fuse Location Provider, Firebase support, and that's available to you on your device as well. It really enables a lot of interesting functionality that we'll get into soon. So as we said before, it's based on a SOM architecture, but it's more than just the hardware modules itself. It's also the software. So Google is providing managed software updates for those SOMs in the form of what's called a BSP, or a board support package. So Google provides the Linux kernel, the drivers, and the libraries that are necessary to run Android on that SOM, and Google pushes updates to those devices itself. So you're a dog feeder manufacturer making little prototypes. You don't want to have to worry about security and updates and looking for kernel flaws. You simply get your updates from Google, you update your software module that runs on the device, and then you're done. So the same Android security team that makes patches for Android will be providing those same patches to Android Things devices as well. So every month or whatever the release cycle is, we'll make new binary updates for our SOM modules and push them out to public devices. And there'll be a developer console that you'll use to maintain those and keep your devices up to date, and also monitor how your fleet of IoT devices is doing. So we've provided a lot of really nice infrastructure that helps make automatic updates and keeps devices secure. Because security with IoT devices is very important. And as we're seeing, lots of devices are having problems out there that are not built correctly, we're trying to do our bit to make sure there's an ecosystem of secure devices out there that are based on Android. So one of the things I find really exciting about Android Things is it's not just about light bulbs and thermostats, but it's about all the really crazy ideas that we're going to be able to build in the future. These devices are very powerful. They're not microcontrollers. They're very high-end processors, similar to what you had in a phone 2 or 3 years ago. And so there's going to be a lot of possibilities for computer vision, for audio processing, and machine learning. And the computing power in these devices keeps increasing every year, and the costs keep decreasing as well. So we're going to see a lot of really interesting things, and we're enabling you to build those devices. And so one of the really nice examples is TensorFlow. So we've ported TensorFlow to Android, and therefore it also works on Android Things as well. It works on both ARM and x86 chips, so you can support any kind of Android Things device that's out there. And we've built some samples, so there's a URL up there to a GitHub project if you want to have a look. We did a blog post about this recently where we took a dog recognition sample and we made it work on Android Things. And so it's really cool because you can take photos of dogs and people and it'll classify them for you. And TensorFlow they've already provided a model called the Google Inception model. And this is a training set of data that Google has built using millions of images that they've trained, and then you can use it to recognize images. And so in the example, you can show a photo of a dog, and it tells you what it is. And so in this example here, I've got my dog Mila, and you point the camera at her, and then it goes, wow, she's a Staffordshire Terrier. So it's that cool that it actually can identify the breed of the dog based on the photo. And so I think my next project, I like doing IoT projects at home for my dogs, so I built a pet feeder last year, but I think my next one is going to be some kind of camera-based thing that detects when they're on the couch and then scares them away from it or something like that. So I've got to work on that. If someone wants to build that, I'll definitely buy it. So TensorFlow is really cool, and it offers all kinds of amazing possibilities of doing machine vision, and it makes it really easy for you. And by using something like Google Inception, you don't even need to build a training set for it. You can just get started straight away. So check out the sample for that. So we talked about the Google Assistant before. So there is a third-party API that we've provided called Actions on Google, which is what you can use to extend the Google Assistant to support conversations with your users. And we call those assistant apps that you can build as a developer. And so we provide something called a conversation API that takes the Google Home's speech recognition. So when the user speaks something, it recognizes the text, generates a string, and it then passes it to your cloud service, and it gives it to you so that you can do something with that string. And then you can generate a reply, and then the reply will be spoken back to the user via the assistant. So it's just strings going back and forth. So it makes it really easy to integrate your own actions, and there's all kinds of demos out here that you can see in the sandbox areas to try them out for yourself if you haven't played with it before. And we have code labs that show you how to build your own actions as well, which is quite interesting. So in the example on the slide here, we have actually ported the Google I/O app to the Google Assistant. So you can actually ask it questions like, tell me what kind of topics you want to know, or when's the next Android talk. So you can ask these questions and have a conversational chat with it to find out what you want to know. And so we really want to encourage people to build conversations that are not press 1 for sales and press 2 for support, but they're much more intuitive. And we have a whole bunch of talks here about how to build really good voice user interfaces, or VUIs. And we have some of the best experts in the field giving these presentations to give you key insights as to how to build really good VUIs. And I remember going to one of the talks, and I was like, wow, I didn't realize that there was so much thought that's been put into this. So there's a lot of research that's been gone into making really good voice conversations, and you can build them now too. Now, the one thing about working with Actions on Google is that the basic API is strings going back and forth. But trying to build those complex conversations yourself is not easy. And you have to, if you had to write code that actually processed those strings separately, you would have a hard time doing it. So we've actually got a tool called API.ai that we use to help build really nice conversation actions that run on the Google Assistant. So let's talk a little bit about API.ai. API.ai has this really simple user interface. You don't even need to be a programmer to use it. And what you do is you give it example sentences of things that you want the system to process. So there's a video I made a couple months ago where we built this personal chef example. And so you could say things to it like, I'm hungry and I want a hot soup because it's cold outside, and chicken sounds good to me, and I'd like a cold dessert and I want it right now. You could give these really complex sentences, and API.ai was able to extract out the key phrases of those sentences and pass it to your webhook so that you could do something with it. Trying to write a regular expression to process something like this is really complicated. And API.ai uses machine learning techniques that you program by typing in these example sentences. It then learns from you, and then as users use your action, it then learns from that as well. And if there's mistakes, you can correct it, and it trains this model to understand the different phrases that people are going to give you. So it's a really neat way of building conversations. and it makes it really easy. And so I've had plenty of people on their design team who've never written code in their life, and they come into API and they start building their own assistant app, and it's really cool with what you can do with it. So we've got a bunch of great samples. If you go to developers.google.com/actions, we have a bunch of great samples on how to do that. And so if you're a beginner, you should start with that. And so finally, we mentioned in the keynote today that the assistant runs on phones, and it runs on the Google Home device, and we have other platforms coming soon. But the key thing to remember, I've had a few people ask me this, is like, well, if it runs on the phone, how do I build an APK around that? And the answer is all of the actions on Google is hosted in the cloud somewhere. You can use whatever cloud provider you want, but the action lives in the cloud somewhere because it's available to every device, Google Home, phones, portable devices, and so forth. Not every device has the ability to install apps onto the device itself. So have a look at the documentation to learn more, but it's definitely something if you're interested in building a conversational interaction with your service, because people are driving, they're walking, they're doing things. They're not always at a phone or at a computer, and this is definitely a way of enabling more capabilities for your service or platform. And so one thing we're announcing at Google I/O this year is a new contest for actions on Google. And so we want to see what kind of amazing, cool assistant apps that people like you build. And so we're launching this contest here at I/O to encourage that. So we've got over 20 different prizes, and one of the biggest prizes is a trip to Google I/O next year. So you don't have to wait in line for a ticket, and that's one of the prizes. So we really want to encourage you all to go out there and build assistant actions, submit them, try them out, and see how that goes. And there's a link, g.co actions challenge, that you can use to learn more about this. So next, we also have announced the Google Assistant SDK. And this allows you to embed the Google Assistant into custom devices that you build yourself. So you're no longer limited to just a phone or a Google Home. You can now make your own crazy device. And so if you look outside in the sandbox area, we have Deep Local, who's a partner of ours. They made a drink making machine that you can walk up to, press a button, tell it what you want, but you can have a conversation with it. You can say things like, oh, I'm feeling a bit thirsty. I really feel like whatever the drink is. And with the power of API AI, it helps to understand what you're trying to ask for, and it helps to tell you, and it helps to understand what you want. And so it's really amazing what they were able to do by embedding the Google Assistant SDK into their device. And they built it really quickly too. So recently, we announced in the Magpie magazine a kit called the AIY Projects Kit, which is that cardboard box that's shown at the top there. So it's a really nice kit because it's a cardboard box that has a button, a speaker, a microphone, and it all wraps around a Raspberry Pi. And we gave these kits away to tens of thousands of people, and every one of them has the Google Assistant built into it. So you push the button, talk to it, and you can do stuff with it. So I'm really curious to see what people are going to do with this kind of stuff, because the possibilities are endless. You can talk to your cocktail machine or whatever, so it's quite fun. So how can you go about embedding the Google Assistant SDK to work in your project? So we have a dedicated session at I/O about embedding the Google Assistant in, and has a lot of detail. The engineers on the team are going to go through code samples in a lot of detail, and they're going to have demos. But I'm just going to give a quick little summary here. So if you look in the box of the AIY projects, it just has a microphone, a speaker, a few cables, and some buttons. So it's very simple. And we run on any Linux or Android things-based device. So we have support on both platforms. And the nice thing is that the software, the API that uses to talk to Google is based on something called gRPC, which is an open source portable library that's designed for doing this kind of interaction. And within like a week of launching this, we had all these people popping up with contributed projects, porting it to all kinds of different platforms. So I was quite excited to see the huge interest in this and the porting to many different platforms. It's really easy. And so you can run it on pretty much anything. The next thing is that you can use a button press to activate it, because you don't always want to use a hot word. But we do provide a library that adds hot word support too, so that you can trigger it just like we do on our consumer Google Home devices. So you can say, hey Google, talk to it, and it does the recognition, and then it does everything just like you do on a Google Home. So basically, you show up with your hardware, speaker and microphone, and then you hook it all together, and then you use actions on Google to implement the rest of your functionality. And the actions on Google that you build work on either the device you've made, but it works on any device that the user had that they're logged into. So there are a lot of exciting possibilities. So as you saw from the cocktail machine, that's a pretty crazy idea. And I'm very interested to see what other crazy ideas people come up with and see it online and so forth. So that was a little tour of some of the developer platform extensions that we provide for Android, the Google Assistant, Actions on Google, and the Assistant SDK. But you might want to do even more than that as part of building a ubiquitous computing experience for your users. So you might want to connect up your devices and coordinate them, and now we're going to talk about how we go about doing that. So today at Google I/O, we announced the Smart Home initiative, which is our support for home automation. So we've supported consumer devices for a while, but now we're opening this up to third-party developers so that anyone can build a device that integrates with our smart home. So if you go over to the tent over there, you can see a variety of demos that we've got where you can play with commercial devices that are available, but now you can build your own. And you can integrate them into what we call the home graph. So the home graph is a diagram of sorts that knows the state of all of the devices that are in your house. Your light bulbs, your thermostats, your doors. It remembers how bright your lights are at any particular time and what color they're set to. And with the home graph storing this information, you then have the ability to speak to the Google Assistant and to make changes to it. So you can say things like make it warmer, or turn off all the lights, or dim the lights just a little bit. Now, dim the lights just a little bit requires knowledge of the current brightness and then what a little bit means. And so Google handles all of the parsing of the language to extract out what you're trying to do. It goes to the home graph, makes the changes, and then it sends commands to all of the devices to change their state so that it matches what the user desires here. And so device makers can now build these things really easily, whereas before it required you to have a separate app running on your phone that you would have to press, but now you can just be sitting back on your couch and you can just speak to your Google Home device and it just does everything for you. So it's kind of cool. So how do you do this? I'm going to quickly go through an example. There is a talk that goes through this in complete detail, where they're going to show demos and go through the example line by line. But basically what happens is we've provided a sample, which is on our developers google.com/action/smarthome. And there's a Node.js sample that we've provided. So what you do is you spin up the Node.js example on your cloud server of your choice, and then you submit an action package that tells the Google Home that that demo exists. The next step is you go to your phone and you have to register the devices that you own. So you click on your smart home integration, you type in your username and password for that particular OEM's service, and then it does an OAuth login and it returns OAuth credentials to the Google Home, so the Assistant. So the Assistant now has an OAuth login token that it can use to control your devices. So when it comes time for the user, when they say something like dim the lights a little bit, now everything springs into action. So dim the lights a little bit goes to the home graph. The home graph then decides how much to lower the dimness of that light bulb by, and then the light bulb is sent a command that's through the API that we show you, and then the command arrives at your cloud service, and then you can send the command to your light bulbs with however it's implemented and change the light bulb state. So it's really designed to integrate with existing infrastructures, because lots of companies have different kinds of light bulbs out there, and we want to make it really easy. So it hooks in to all their existing cloud infrastructure really easily. So you write a really small cloud service and hook it all in, and it just works. Now, sorry. One of the really nice things about this initiative is that we integrate devices across all different OEMs. So you don't need to mention the name of the manufacturer when you want to change a light bulb. You just say turn all the lights on or turn all the lights off, and it does all of them that are connected to the home graph. The other thing you can do is you can embed the Google Assistant SDK into a device like a light bulb, and then you can talk to the light bulb itself. So when you speak to the light bulb, you can say turn off, the light bulb will turn off. But you could also say, turn all the lights on in the house, and then it'll send the command everywhere. So you have the ability to embed the Assistant into the devices itself, and there's all kinds of combinations you can do here. So the cocktail machine example, that's also an example of a device that has the Assistant built in, and it's a device of its own that hooks in to the ecosystem of things. So That's the really nice thing about the Google Assistant SDK, is it brings both embedding devices and the smart home initiative together. So definitely go check that out in the sandbox area. There's a bunch of really nice demos, and we have examples that you can actually play with to sort of see how they work. As a few other developer products, let's go through them quickly. We also have Firebase. So Firebase is an SDK that many of you are familiar with for writing Android apps. It works on the web, Android, iOS, and it's a very portable library that runs anywhere. Now, Firebase Cloud Messaging is a part of that, and it allows you to deliver quick, reliable messages to devices to wake them up. Now, normally when you build IoT devices, the quick and dirty way is to do polling, where you poll once every 5 minutes to find out what your latest command is going to be. But that's not very efficient, because if someone says change the lights, it'll take 5 minutes. So Firebase Cloud Messaging is a great way of delivering messages to your products between devices, if that's something you want to do. And it provides very fast updates, and it's available currently everywhere. And because Android Things supports Google Play services, it then supports all of the cool features of Firebase as well. Firebase also has a real-time database capability. So it's cloud-hosted, it's based on NoSQL, and it lets you store and sync data between your devices in real time as well. So maybe the smart home thing is not for you, and maybe you want to do your own kind of synchronizing between devices. You can use that here as well. And once again, because Android Things supports all of Firebase out of the box, you can use this stuff for free without having to do any extra work. And actually, one of our engineers on my team, he made a sample where he actually ported Firebase to work on Arduino devices as well. So there's a URL for there if you want to do that. That's useful for really, really cheap devices if you want to embed Firebase into that. The nice thing about Firebase, the database, is that you don't even need to provide your own server. If you just want to synchronize data between devices, you don't need to have any cloud hosting, and we handle all of the provisioning and scaling and so forth. And so we've provided a whole bunch of samples for that, so go check that out if you're interested. And finally, for Firebase, we also have the ability to store larger user-generated content. So you might have like a doorbell where you press a button and it takes a photo, and you want to synchronize that photo over to a device that's running an app that you've got. So this is great because you can take that photo, it'll store it in Firebase for you, and then make it available to all of the other devices that are part of your ecosystem. So you can store photos, videos, large files. It's kind of nice for things like this. And once again, it works on Android Things, but also it's something that you might want to consider using on Android Wear or Android TV as well. Because remember, they're full Android devices that have the same capabilities as phones, so you can use it there as well. And then just yesterday, we released a blog post where we announced a new initiative called Cloud IoT Core, which is a fully managed service on the Google Cloud platform that allows you to securely connect millions of IoT devices to Google Cloud. Now, the reason this is cool is because it scales automatically and it works anywhere in the world. We provide endpoints everywhere that you don't have to worry about. You just simply upload your data and it works everywhere in the world. It handles millions of devices. And imagine a scenario where you've got an enterprise where you're building millions of thermostats or power meters for the power company or something. Now, every one of those power meters is going to be logging data every minute. And there's millions of them. So imagine millions of devices logging data every minute. You're going to end up with terabytes and terabytes of data really, really quickly. So Google Cloud is ideal for this kind of thing because it's built to run really mega large applications. And so we support the ability to use standardized MQTT messages. So we support lots of different protocols like that, and you can access all your data very easily. And the nice thing is you can use cloud services like BigQuery to analyze that data and extract out really useful information that you might not be able to see with small data sets. So once again, we have a bunch of talks about Cloud IoT as well. We've got 2 of them. One's a combo session about Android Things, and another one is just about Cloud IoT and all the concepts. So definitely check out those 2 talks if you're interested. They've got demos and samples and so forth that you can learn more about. So we're almost out of time. So that was a quick whirlwind tour of some of the things that Google provides to support ubiquitous computing and the Internet of Things. And we think they're really useful for making amazing, powerful, and secure products that scale to a worldwide audience. Because you can't just build things small, we've got to build big because there's lots of people out there. Every single one of the things I mentioned here has a dedicated deep dive session at I/O, and so you should definitely check that out. And also, if you can't make it to those talks, they're all being recorded, so don't worry, you can catch up on them later. The other point about Google I/O that I want to highlight is that it's all about meeting people and talking to the engineers who work on the products. So if you look at the top of the map, there's a code lab area. Not everyone's been to the code labs before, but you can actually sit down and work on a machine and try these products out yourself. We've got devices plugged in, and it's a lot of fun. And we have the engineers who work on those products standing around to answer questions and help you out. We have office hours on the bottom right, where you can show up. We've got 3 sessions for Android things, where you can come and meet the engineers and ask questions. And also, we're going to be around. So if you see any of us walking around, come and talk to us and tell us what your idea is, if you've got any problems, or whatever. So we look forward to hearing from you. So finally, what's next? So if you want to learn more, join our Google Plus communities. So we've got 3 of them for IoT, Actions, and Assistant. And we do a lot of postings there to keep people up to date. I also am a developer advocate for IoT and Android things, and also the Assistant. So follow me on Google Plus and Twitter if you want to keep up to date with everything that I'm working on. So what can you do with all this? So there are all kinds of possibilities for IoT and the Internet of Things. And think about cool ideas you can build, but also I want everyone to think about what things you could do to help people who are less fortunate. Think of people with accessibility issues and people who could benefit from having more computing in their lives to perform tasks they can't currently perform. This technology is going to change the world, and I look forward to building it with you. Thank you very much.